do some quick changes to the math assessment. So in particular, what we're doing is we're going to be looking at the rubrics. So this is actually grade 5. Oops. This is grade 5, module 4, MMA. So on the left, I'm going to keep the original, and on the right, I'm going to do some editing. This is the current test from this year, so it could be that the 5th grade team has actually changed this at this point. But just so you know, this is this year's test currently, and I'm just using it as an example. So in particular, what we're looking at here is 508.1, 508.2, 5NF3, 5NF4, 5NF6, 5NB1, and 5NB2. So we're really looking at writing and interpreting numerical expressions, applying and extending previous understandings of multiplication division to multiply and divide fractions, converting like measurement units within a given number, within a given measurement system, and represent and interpret data. Oops. Those are the things we're going to be looking at in this assessment. It's really important to make sure that you're focusing on the standards. That is like so key. I can't overemphasize it. That the rubrics have to keep those standards in mind. Every edit you make to the rubric really needs to be in service of those standards, because those rubric scores are going to be transforming into standards achievement when we look at the master manager reports. So we want to make sure that that's the case, that we keep those standards in mind. So for item 1 is 5NF4A and MD1. So NF4A, NF4, apply and extend previous understanding of multiplication to multiply a fraction or whole number by a fraction. So multiplying fractions by a fraction, or multiplying a whole number by a fraction. So interpreting the product of A over B times Q as A parts of a partition of Q into B parts. Equivalently, as a result of a sequence of operations, A times B divided by Q. For example, use a visual fraction model to show, okay, blah, blah, blah. Excuse me. So that's NF4. Oops. And then MD1 is converting amongst units. So I'm going to guess this item is about, is going to be converting units using fractions times whole numbers and fractions times fractions. Go back up to the question, and we see multiply or divide, draw a model, explain your thinking. So we've got multiplying fractions times whole numbers up here in A, B, C, and D, and then we've got converting units. Perfect. And then we go back to multiplying whole numbers times mixed numbers in this case. Okay, so how do we evaluate this? So it looks like the current rubric is asking us to student draw, so the 3, a student draws valid models and or rows of the code. So here's what we're doing. We're actually going to be combining the 3 and the 4, and then we're going to move some of the current 3 into the 2. Okay, so I'm actually going to get rid of these. Okay, so this is going to be some evidence of standards mastery. This one's going to be strong evidence of standards mastery. And I'm going to state 3 points, although we're going to get rid of all this extra space. Don't need it. And then 4 is going to go away completely, so I'm just going to delete that. And then little. All right, now we're getting rid of the 4, which means there's just 3 choices. You either don't have it at all, you kind of have it as the 2, or you definitely have it, which is the 3. 1 is asking students to multiply fractions and decimals and to convert. So in order to get a 3, what does that look like? Student draws valid models and arrives at the correct product for 6 or 7 items. So let's go back up and take a look. Okay, so as a team, we have to decide, all right, so there's 8 possibilities here. And students are asked to draw a model to explain their thinking, so they're asked to explain. And that's one of the key components of strong evidence standards mastery. It's not getting correct answers. It's being able to explain your thinking well. That is the key piece. If students can explain their thinking and they somehow get the math, the actual calculations incorrect, that's actually okay, as long as they got the application of the standard. So in this case, let's go back and look at the standards for a second. So apply and extend previous understandings of multiplication to a multiplying fraction or whole number by a fraction. Okay. So student draws valid models and or arrives at the correct product for 6 or 7 items. I'm going to change this. Student draws valid models. Student explains their thinking appropriately through visual models and or words. On a majority of the items. Okay, so this means if they do that on 5 of the 8 items, I'm going to give them credit for this. And that may seem like a stretch, like what about the other 3? And the other 3, they make a mistake, but the majority, they get the reasoning correct. And that is the biggest thing. Now, does that also mean that they're very likely to get the correct calculation? Yes. Does it also mean they're very likely to get the rest of them? Yes. It's probably going to be rare that you're going to have a student explain well on 5 and the last 3 they don't explain well. Now, it could be that these 2, which are key parts, and these 2, which are key parts, what if they get these 4 correct, but then they don't get these? They're going to get 4 out of 5, and which is going to put them at a 2. Which is what I would expect. If they get 1 of these, but 3 of those, the F, G, and H, they get incorrect, let's say, but they do get E correct. What does that tell us? Well, something in particular. But in this case, maybe we want to make a stipulation. Maybe we say that student explains their, I'm going to change this to, instead of just through visual models words, the majority of the items, including at least 2 items from E through F. Okay, so half of those 5 that they get correct, 2 of them have to be in this portion. It has to be E, F, G, and H. These aren't actually part of the standard. It doesn't say anything about mixed numbers. It says fractions or whole numbers. Now, you can make an argument that a mixed number is a fraction and a whole number, and lots of things there, but it involves an extra step. So if they get 1 or both of these wrong, I'm not actually that concerned. What I'm really concerned about is these 6. These 2 give us a little bit of hint into an additional or a little bit deeper understanding, or actually not really deeper, just you facility with mixed numbers, which maybe a student who doesn't get those doesn't have. So the current 3 is this. Now I'm going to now for the 2, it would be not quite this. So I'm actually going to take this, Control C, put it here, but instead of a majority, student explains their thinking appropriately through visual models and or words on fewer than a majority of the items. And I don't need that piece because if you don't get it on the majority, they're not going to get those. That's pretty much guaranteed. This one, I'm just going to change this to students. That's little evidence of understanding Shows, not has. Shows. All sorts of trouble here. Okay. Little evidence of understanding. All right, and that would be 1, 2, 3 for item 1. 3, strong evidence. 2, some evidence, but we're not quite there. And little evidence here. I suppose you could add another sentence here to 2 to say, the student explains their thinking appropriately through visual models and or words on fewer than a majority of items. And there is some evidence of understanding. Or something like that. There is some evidence of understanding. There is, the student works shows partial understanding, maybe that. There is evidence of a partial understanding of standards. Maybe something like that. So that helps distinguish between the 2 and the 1 where there's really nothing. So if I were editing this assessment, I would go through and actually change all of these items in the same way. And I'm going to do that now. I'm going to pause the video. I'm going to do that now, and then we're going to reflect on the video. All right. So had a chance to do the rest of these. It took me about 20 minutes to do the last 5 pieces. I just want to go through them quickly here. So item 2 here is looking at this bar model and this number line and trying to write a multiplication equation for the diagram and then solve the diagram. So item 2 is NF4A and NF3, so let's look at that quick. So NF3 is interpreting a fraction as division of the numerator by a denominator, solving word problems involving division of whole numbers leading to answers. Okay, and then 4NF is interpreting the product of A over B times Q as A parts of a partition of Q into B parts. Or equivalently as a result of a sequence of operations A times Q divided by B. All right, so we're interpreting fractions as division problems. That's what we're doing. Trying to visualize that and interpret it. So in this case, what we're doing is we've got 3/4, right? 4 pieces. 3 of the 4 pieces are highlighted, and it's 3/4 of 3. Right, so 3/4 of 3 is 3/4 times 3, and so that would be 9/4 or 2 1/4, right? So that would be the solution. Oh, it's written here. Oh, epiphany. So while I was doing the rest, seems to make sense to have a column of solutions. So it's right here in the rubric, but in that case, it's actually somewhat easier to transition these rubrics because we can just leave the solutions part of the 4 there and then just reword 1, 2, and 3. So anyway, so I changed that so that 3 actually has less written in it. And it's the solutions is in the final column. Okay, so in this case, what we've got is for the 3, student appropriately explains the mathematics through the visual model, symbolic representations, and our words. So we want students to appropriately explain the math here. What are they doing and why? In symbols, representations, and words. So if a kid just writes 2 1/4 and nothing else, we have no idea what they're doing. We don't know what they're thinking. They could have just wrote that from someone else next to them, whatever. We want to see their thought process. So I would want to see at bare minimum 3/4, and maybe label that bar would be great. And then of 3, either writing 3/4 of 3 or 3 over 4 times 3, and then actually doing the mathematics and getting the answer. Now, if the student does the 3/4 times 3 and doesn't get the right answer of 2 1/4, they get something else, they stop at 9/4, whatever, but they still set the problem up correctly, They just messed up the calculation. That's a 3. And that's a 3 by this language also. It's appropriately explaining the math through the visual model, symbolic representations, and words. So the 2-pointer here is partially explains. So let's say they get 3/4, but they don't get 3. Let's say they get 3/4, they say 2, or they say 4 times 3. They get part of this, but they don't get the whole thing. In that case, that would be a 2. If the student wrote nothing, or if they wrote something that did not connect with the visuals at all, or the situation or the sentences at all, then that's a 1. For 3, we're asking whether or not each of these 4 expressions is equivalent to 3/5 times 6. So this is really asking kids to do. I mean, this is connected to 508(1), to use parentheses, brackets, blah blah blah. But it's also interpreting products as parts, rewriting. NF3 and NF4, I feel like, are really mixed into this as well. This is actually a really good problem for this particular test, I believe. Anyway, it's asking kids to say, well, is it the same or is it not? So in each of these cases, they have to make that determination and explain why. And it's in that explanation that's where the math is going to be. So the 3, student correctly identifies and explains why at least 3 of the expressions are or are not equal to 3/5 and 6 using visual. So if the student gets 3 of the 4 correct and explains them, the explanation is the important part, then that is the 3. The 2 here is that only partial, and the 1 would be not at all. They're unable to do that. So if they get 1 or 2 of them right, it's a 2. Explained correctly as well. If they get at least 3, it's a 3, and if they get none, then it is a 1. Again, we've got the stuff written here. For the 4, well, I'm going to tell you what. I'm just going to show it on the screen so you can see it. I'm not going to explain them all because this has already gone on long enough. But I do want to mention that it did take some time. But I think in the end, this rubric really allows a teacher to decide, did the student understand it? Is there evidence on the page the student understands the math, the standards we're getting at? Not so much the calculations. The calculations are a part of the math, but they are not the math. In fact, the calculations are going to be done by computers. So we're much less worried about the calculations, much more worried about whether students understand the mathematics. How do fractions work? How do you multiply them times other things? What do they look like as visual models? Not so much what's 3 times 2 divided by 4. All right, and that is the end of the explanation for how to transition these rubrics.